Hello again. Today we start our next lecture on algorithms design and analysis course, and the topic is merge sort. Merge sort follows the rule of divide and conquer to sort a given set of numbers or elements recursively, hence consuming less time. And really the quick sort also uses the divide and conquer algorithm. First, a few notes about divide. What is divide and conquer? We can break a single big problem into smaller sub-problems, solve the smaller sub-problems, and combine the solutions to find the solution for the original big problem. It becomes easier to solve the whole problem. There are three steps involved in the divide and conquer. First, divide the problem into smaller sub-problems. Second, conquer the sub-problems by solving them. The idea is to break down the problem into atomic sub-problems where they are actually solved. And the last step, we combine in the merge sort, we merge the solutions of the sub-problems to find the solution of the actual problem. How merge sort works? In merge sort, we break the given array midway. For example, if we have 100 elements in the array, then we break the array down into two sub-arrays, 50 elements each. And these sub-arrays are repeatedly broken into smaller sub-arrays until we have multiple sub-arrays with single element in each one. An array with a single element is already sorted. Next, all these sorted sub-arrays should be merged step by step to form one single sorted array. If we have the following array or list of elements, 5, 2, 3, 4, 1, 9, 7, 6. According to merge sort, we divide this sub-array, this array into two sub-arrays, 5, 2, 3, 4, and on the second sub-array, 1, 9, 7, 6. Again, we divide the sub-array into two parts, 5, 2, 3, 4, and this one as well, 1, 9, and 7, 6. Again, we divide this into two sub-arrays, 5, 2, 3, 3, and 3, 4, 1, 9, 7, 6. Now we have only one element in each sub-array. One element is sorted by itself, so this process is called partitioning, splitting the array into sub-arrays. And on the analysis of the complexity, you can observe that the complexity of this partitioning is log 2 of n, since we divide each time into 2 parts. Now we start with the merge process. 5 and 2, if we are going to sort in ascending order, then we have to swap them. Three, 4 are already sorted. No need to do anything. They are in the proper place. 1, 9 as well. But 7, 6, we have to write 7. Sorry, we have to insert 6 here and 7 here. 6, 7. We repeat this process. 2, 5, 3, 4. We are now merging. 4 elements. 2, 3, 4, 5. 1, 9, 6, 7 are merged into 1, 6, 7, 9. I'll show you how to merge. Now we have to merge these together on 1, 2, 3, 4, 5, 6, 7, and 9. And this is our array sorted. Now regarding merging, suppose, for example, that we have these two subarrays. First, note that the first subarray is sorted and the second subarray is sorted. Now we need to merge them. Into one array, into one sorted array, etc. We organize two counters, I and J. We compare 4 with 1. 1 is less, so we insert it here. And we increment J to point to the next element. We're done with this element. Now we compare, I is fixed. We compare 4 and 2. Since 2 is smaller than 4, then we insert here 2 and we increment J. 4 and 3, since 3 is less, we insert here 3 and we increment J to point here. Now we compare 4 with 6. 6 is greater than 4, so we write here 4. J is fixed here. Now we increment I. We compare 5 and 6. Since 5 is less, we insert 5 here. And we increment I. Now we compare 7, or the element pointed by I, with the element pointed by J, with 6. Since 6 is less, we write 6 here. And we increment J. I is in its place. Now 7 and 11. Since 7 is less, we write here 7 and we increment I. 8 with 11. Since 8 is less, we write here 8 and again we increment I. 9 and 11. 9 is less, so we increment I. Now 15 with 11. 11 is less, we insert here 11 and we increment J. 15 and 14. 14 is less and we increment J. Since we have reached the end, past the end of the array, we stop and we write here, add the remaining elements from the first subarray. So this is how merging is done. And this helps you to trace the program. I will not spend a lot of time on tracing the program. The algorithm steps, as you see, if we have P start index and R last index, we find the mid, break the array into two subarrays now. One, the first subarray from B to Q, and the start index to Q, and the second from Q plus 1 to R. And we continue this process of breaking into halves until reaching single elements. After reaching a single element in each subarray, we start the merging process. Regarding the complexity, I already told you that dividing each sublist into two parts, this is log 2n. And we, to merge the subarrays, we need n. So big O of merge sort is n log n, and it's one of the fastest sorting methods. This is the Python program. Here is our array, and we call the function merge sort, passing the array to it. As you see, here we split the array into left part and right part by, we have integer division by 2 here, and we call merge sort left and merge sort right until length of array becomes 1. We reach this point after partitioning the array into elements of size 1. Now we initialize both all I, j, k to 0, and we start a next loop while I less than length of left and j less than length of right. Here, if left I less than right j, then we move the element from left to the array, we increment I. Otherwise, as you noticed in the example, we move to array sub k the right element and we increment j. After that, k is incremented, and we continue. Here you can trace the whole program and test it on different samples. And again, the complexity big O is n log n. Thank you for watching.